Alright, Precalc concept 33E. We're going to now put some different ideas together and we're going to solve some more trig equations. This time we're going to use some of the identities. And remember that you have these identities on your toolkit sheet. Let's start off with an example. Alright, I have a trig equation here. One thing you might notice as a difference to previous problems is that I've got sines and cosines mixed together and I'm expected to solve. And in general, you want to always try to be working with one function instead of two different functions. Good news is we have a way to relate sine and cosine to each other through one of our trig identities. So the proper way to kind of start this problem is to remember that cosine squared is simply 1 minus sine squared. So this looks a little more complicated, but our benefit here is that I now have all of my functions the same function, right? I don't have any mixed functions anymore. It's just all in terms of sine. I'm going to clean this up a little bit. I get 2 minus 2 sine squared x plus 3 sine x. And I'm going to do two more things. I'm going to reorder these so that I have the greatest power first and the kind of single power second and the constant power third. And then I'm going to make the leading term positive. Hopefully you can see where we're heading. We're going to need to factor this. So I'm going to make the leading term positive. And here's what I get. This becomes basically one of our quadratic problems. I'm going to do the substitution so we can kind of see it clearly. But this is really a quadratic of this type, 2w squared minus 3w minus 2. And hopefully you could factor that without too much trouble. Oops, I'm going to have 2w and w. And if I do minus 2 and plus 1, I get my factored form. Let's take this up over here. And what I have now is two statements, w equals -1/2, or w equals 2. I need to remember that w really stands for something, so in this case it's the sine function. And now I'm once again back to simple trig equations. So we started with these. You should be able to solve these pretty simply at this point. Sine of x equals -1/2 is these two angles. That's going to be 7 pi over 6 and 11 pi over 6. And sine of x equals 2, if you think about that, is a no solution answer. Right? We can never have an angle whose sine is more than 1, and so there is no solution to that piece. Alright, our final answers for this original problem are there only two angles that satisfy the original equation. Alright, here's a U-try. It's very similar to the last one. So think about an appropriate trig identity to use, and then use your factoring and solve skills to solve the problem. Okay, so hopefully you thought of the trig identity again that allows us to replace sine squared with 1 minus cosine squared. After that I can kind of move stuff around so that I have something in quadratic form. This time I didn't do the w substitution, but rather just factored as written. If you need to do that off to the side, feel free. But ultimately I end up with two simple cosine statements. One of them has answers in the first and fourth quadrants, and once again I have a second half of the problem that has no solution. So my final answer should be pi over 3 and 5 pi over 3. Alright, here's another example. You may notice this one has a double angle in it. And so I need to think about what cosine of 2x is the same as. So there's a common identity of cosine squared minus sine squared. But I still have a problem at this point because I still have sines and cosines mixed together, which is generally a bad thing. I have two sines and one cosine, so hopefully it makes sense to you that I want to further substitute out. So you're actually using two identities here, and this is what I end up with after that. The good news here is everything is in terms of sine only. And I can start putting stuff together. I have a minus 2 sine x. I have a plus 3 sine x. And I have a minus 1. Again, I'm going to... Oh, sorry, I left off my squared there. I'm going to, again, make the leading term positive so that I can factor. And so this is what I come up with. And without doing the substitution, again, I'm just going to write this, see if I can factor. 2 sine x and sine x are going to be my first terms. I know I'm going to have a minus 1, minus 1. The product of that is positive 1, and if I check my middle term, it would in fact be minus 3 sine x. A lot of times the factoring is the most challenging part of this. Once I have my expression factored, I can set each term separately equal to 0. So that's going to be one mini problem, and this is going to be another. I like to do my little sketches here, so my answers for the first factor are going to be pi over 6 and 5 pi over 6. And my answer to the second one, if I think about the places on my unit circle where the sign is 1, there's only one answer to that. In total, 3 answers. There's a lot of steps to these that makes them a little bit harder, but you can see that the strategy is to try to get your expression into one trig function. In this case, it leads to a quadratic that can be factored and solved. All right, let's take a look at this one. This is another function that's got, another equation that's got a double angle formula in it. So I'll give you that hint. You need to deal with that off the bat. Take a few minutes, think about your identities, your solving skills, and see if you can come up with the answers for this trig equation. Alright, so I want to use my double angle formula for sine. You have that on your toolkit sheet. Take advantage of that. That leads to an expression that can be factored. We still have the problem of having sines and cosines mixed, but the good news is after factoring, I don't have that issue anymore, so you may have encountered that challenge there. And once again, I have two simple trig equations to solve. Cosine of x equals 0 has these two answers, and sine of x equals negative 1/2 has those two answers. All right, one more example to look at that's a little bit different that you might encounter. Sine x minus cosine x equals 1 presents a little bit of a challenge because you can't use a Pythagorean identity, and that might be your first instinct. We can't really use any other identities off the bat, and there are no double angles, so you might look at this for a few minutes and not be sure how to start. If your instinct was to think of a Pythagorean identity, you're actually on the right track. So in this case, what we're going to do is square both sides of the equation. Okay, this is an algebraic step that you're allowed to do. You need to remember, though, that squaring both sides of an equation sometimes leads to extraneous answers. So at the end of this problem, we're going to check and see what happens. All right, so let's think about this. I'm going to have sine squared. You're going to have two middle terms that are both sine times cosine. So there's going to be two of those. So my middle term here is minus 2 sine x cosine x. And then I have plus cosine squared x. And that whole thing equals 1. If you have trouble doing that in your head, you can write it out as a FOIL problem. Hopefully you notice something here, and that is that we have sine squared plus cosine squared, and we know that that's equal to 1. So I actually end up with a 1 on the right side of the equation and a 1 on the left side of the equation. And those cancel each other out, right? So basically these two things together cancel with the 1 and leaves me with a 0 over there. All right, I can also divide by a constant. We said earlier you can't divide by a function, but you can divide by a constant. So this is basically what we end up with. And this actually is something that's in factored form, so I can break it down into these two problems. And with that little trick, I actually end up with 4 answers. The sine of 0 happens at 0 and pi. Sine of x equals 0. And the cosine of x equals 0 happens at pi over 2 and 3 pi over 2. Now, we have to remember that because of the squaring step that we did way back in step number 1, that some of these answers may, in fact, not work out. And while tedious, it's important for us to check all 3 of these. So, I'm going to take, let's do this, sine of x minus cosine of x equal to 1. And I'm going to basically test it for each and every one of these. I'll do each one in a different color. So I'm going to first test 0. The sine of 0 is 0, and the cosine of 0 is actually 1. And so the answer to this problem is negative 1, not positive 1. So that's a solution that actually is extraneous and does not check. Let's do a green answer. If I did the sine of pi, right, the sine of pi is sine of pi is 0. Minus the cosine of pi is negative 1, and that one does check, and so pi is a solution. Alright, let's do the same thing over here. I'll do a blue answer. Okay, if I took pi over 2, the sine of pi over 2, let's actually write this out so we can refer to it. The sine of pi over 2 is the number 1. And the cosine of pi over 2 is 0. That's one that does check. And let's do an orange answer. If I do the sine of 3 pi over 2, that turns out to be negative 1. And the cosine of 3 pi over 2 is 0. All those values I'm getting from the unit circle, you may need to take some time to reference those. But you actually get negative 1 here, which is not a solution, right? So of those 4 answers, there's actually only 2 of them that work. This is a little bit more of a rare problem, but there are some times when you square both sides of an equation.